Hello everyone, welcome to today's Industry Solutions webinar. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's Industry Solutions webinars are designed to provide insights into overcoming challenges in an evolving industry in more effective and efficient ways. We'll keep running these webinars and recording them for posting on our YouTube channels, with links through our website. Our previous webinars from these Industry Solutions series, as well as those from our training series, are available online if you missed those. During today's presentation, you'll be able to type your questions along the way, as shown on the screen. We'll answer as many as possible of those throughout the webinar, and at the end, I'll read out some of your questions to the presenter if there's time. Today's webinar, Using FME with 12D Model, will be presented by our co-founder and managing director, Dr. Gregory, who has nearly 40 years of experience in the civil software industry. 12D Model has a very rich data set and attribute structure which is not supported by most file transfer formats. This usually means that only a portion of the 12D Model data can be transferred, and different decisions need to be made depending on what the output format can support. And even worse, accuracy of survey and design data can be compromised. The best solution is to provide clients with a 12D XML file that can contain all the accurate data and attributes and allow the client to make decisions on how they want to manipulate the data for their purposes. But how can this be done? One solution is for the client to use FME. FME from Safe Software reads in 12D XML files, can manipulate the inputted data and write the manipulated data out in hundreds of different formats. This webinar will look at what 12D model data and attributes can be handled by FME. Over to you, Lee.
Thank you, Lisa. Hopefully everyone has been safe during the COVID-19 pandemic. And for those in Australia and New Zealand, congratulations on all the hard work during the lockdowns, which has produced a fantastic result of virtually eliminating the COVID-19 virus in Australia and New Zealand. So that's a fantastic result for everyone's hard work. And I'm looking forward to be able to fly backwards and forwards to New Zealand without having to go into quarantine. So now back to our topic. So welcome everybody to our webinar on using FME with 12D model. Now the 12D model data set. 12D model has a very rich set of data that you're allowed to create from super alignments, superstrings, which can have then string attributes, vertex attributes, segment attributes. We can also have round and box or culvert sections in those strings. We also have water strings, which have nodes and links, and again can have different cross sections. We also have tins and super tins and tri-meshes. So we have all this different data, which is very difficult to often give to other packages. So that is our big problem. Many transport formats which you go through to go to other packages do not support all of those 12D model data types. And even with a particular client, they have different applications they might be running, and they would potentially require different data for those different data sets. For example, for surveying, you tend to use superstrings, and you can have string, vertex, and segment attributes. They're all very important, especially with the looking at underground utilities, where you have to not only have the vertex attributes saying what the quality is, but also the segments can have different qualities as well. So they tend to need, surveying tends to need to be able to get superstrings and lots of attributes about what they were doing. For design, again, you have superstrings and potentially more pipes and things, and also alignments, which a lot of packages do not support alignments. For construction, again, all the data of above, including alignments, because when you're setting out data for construction, for a road and things like that, you always need an alignment. Then we have GIS systems. Now, GIS systems are a little bit restricted because most of them take points, polylines, and polygons, and only string attributes. So they can't take vertex and segment attributes. So that's a different type of data set that you have to use from the other ones. And asset databases, Well, often they don't care about geometry at all. All they're interested in is attributes. An unusual thing though, and it's funny to say, but some client applications require inaccurate data. Now, an example of this is that surveyors go out and do as constructed of, say, a drainage network or a sewer network, and they'll go and pick up where the pits are and information about the pits, and then they'll pick up the pipes, exactly where the pipes are in the ground. But when you go to some GIS systems, they require the pipes to go from the middle of a manhole to the middle of a manhole, which is totally not what happens in reality, but that's what they need to be able to connect their data together. So in that case, you have to take the ends of the pipes and move them. So you're actually having to have inaccurate data. So it would be good if the client could do that themselves, so you just give them your proper data. Having all these different types of files means you're going to have multiple sources of truth. And it's good to be able to just give your clients the one source of truth, which is exactly the data you've got. So that's the problem we have with data going around to different applications and different systems. Now, all 12D model software can write out a project in 12D XML format, and that will put out all our data, all our attributes and everything there. So a solution to our problem is to provide 12D more data just as a 12D XML file. So then all the 12D model data is transferred and the client can select the appropriate parts of the data for each of their different applications. So you're not having to play or fiddle or select what data, you can give them all of the data. There is one problem with this solution. Although many software packages read 12D XML, some software cannot read all of the different objects and attributes that we have. And some software cannot read 12D XML at all. So a solution, and this is what we're talking about today, solution to this problem is if the client who you're providing your XML data to, if they have FME, that can read in 12D XML file, and inside the FME database, they can manipulate the data appropriately and then write out the data into a file suitable for that particular application for the client. So that's what we're going to look at today, how FME can do this and what sort of things it can handle in the way of 12D model data. So first, what is FME? It stands for Feature Manipulation Engine, and it's from Safe Software in Canada. FME, it's actually a batch program. It can read data in a large number of formats into their FME database. I think there's over about 400 different formats it can read in. And then it has numerous operations it can do to modify that ingested data. So it can transform it, do all sorts of things to it, and then it can write out the transformed data out into a wide variety of formats. It also runs as a batch system. So that means if you set it all up for different file types, you then can run it as batch and you don't need any interaction with it. It also reads 12D XML files. And even more interesting is the 12D XML is included in the FME base. So everyone who purchases FME, they're able to read 12D XML files in. Well, what data can be read by FME since we do have this rich data set? So starting off, just looking at something like a superstring. And as you all know, you have your superstring, which obviously has the coordinates. It's got arcs and things like that in there as well. It has string properties, string attributes, vertex attributes, and segment attributes. So if we write out a 12D XML file of that and say read the data into FME, and what you're seeing here is what would look like in FME. And basically, it tries as much as possible, if you look at it graphically, to do the line work and things, although it's not a graphics package. It's really all about working with the data and manipulating the attributes. And so it brings in all the string properties. So you've got information on the right-hand side telling you about the things like the string name, what its color is, all that sort of, whether it's a break line or not, all that information goes across. It also can bring in the string attributes. In this case, there's only one string attribute, so they're available. It also can bring in vertex attributes. In this case, this string had 1 on number 40, saying it was a vertex attribute. And it can also bring in segment attributes. So all those are in the FME database, so then you can start manipulating and doing things with them. It also can bring in, if you've got diameters or widths and heights for the cross-section and thicknesses, that also comes in there as then available for you to use. And there's also coordinates for all the points. So all the data you would expect is in there that you then can manipulate. So most things with the superstrings come across quite happily. Even though you might see something drawn, it is all there in the attributes that you can then manipulate. Now for tins, I have a tin in 12D model. Yes, and again, it can be written out to FME and all the tin attributes go over as well. It goes over as an IFME mesh object, and you can see it on the right-hand side there. And it's got all the attributes as said, but it also has all the vertices, or to make up all those triangles, it gives you which vertices make it up. And you can also have all the coordinates for each of those vertices. So all that information is available there in the FME. Now, it doesn't actually know it's potentially a tin as such, but in this case, you're not going to be manipulating it, so you're just trying to then write the data out. So as I say, it's a FME mesh object. With trimeshes, again, we can write trimeshes out to FME, and they also go out to FME mesh objects. And it's just like for your tin, same sort of idea. All your attributes can go out with your trimesh. It also has the vertex information and then also the coordinates for each of those vertices. So all that information for your trimesh is available for you. And in most cases, the trimeshes, it does do a very good representation of them on the screen when you look at it. Similarly, here's other trimesh, a more complicated one that we've got that goes across quite happily. The next type of thing is a water string. Now, a water string is a water network, is quite a beast as far as it's got links, nodes, pipes go into each other and things like that. But the information is very similar to a superstring. So with a water network, again, we can write it out and FME can read it in and displays it as much as it can. And all your nodes, or in this case, listed here as pits, all those attributes go across. So all the attributes that you have you normally would have in your water network, and you often have a few hundred of them when you do a full analysis, they all can go across to FME. So then people can cherry pick which things they want of those, but you can give people all the results. And similarly, the links or their attributes, the pipe attributes go across as well, which is then attributes on every pipe, plus all information about its diameter, thicknesses, and so on. So, yep, all that information goes across to FME quite happily. Super alignments. Now, this is an interesting one because super alignments have both horizontal and vertical geometry. But when we write that data out from 12D, it actually goes out and breaks it up into little segments, horizontal data for the horizontal segments and vertical data for the vertical segments. And again, FME can read in those different segments and record the information about them. So here's some super alignments that have gone across to FME. And first you've got in there, you've got your header data, which tells you things about like the string name. In this case, it's RS2A01. Its color, line style, all that information is there in the header information. You also have all your horizontal data. And what the horizontal data is, this is the various segments that make up your solved super alignment. And so again, you can have information here. In this case, it's got coordinates and things for each of the parts. It then has information about whether there's an arc or a clothoid or a transition on those segments. And similarly, we have vertical data. Again, because it's broken up in segments, they all go out to FME, and again, you have the information about the coordinates for each of the start and end points of those segments, and then the type of segment it is. That is, whether it's a parabola, or whether it's a straight line, or whether it's an arc. Because with vertical data, that's not actually in XY coordinates. They're in the coordinates of course change and height. So that data is all available there for you. So for example, here we have a transition, say, where we've got a clothoid inside 12D model, and it's got a start radius, an end radius, and a length. You can have a start and an end radius. That becomes a partial transition. And again, that information can all then be passed across to FME. And you would then see things like in here, it's got the type that it's a clothoid transition in this case, and it's got the start radius, the end radius information in there, as well as then the coordinates for all the parts of the transitions. So that's basically the most fundamental things we've got in 12D model, which can all go quite happily across to FME. One other thing that's in our XML file is the project attributes. Now, they also can be written out when you write out a 12D file, and they can go across there. In this case, you can see there is a thing with the project attributes. So just like all the other attributes, they will be displayed and you can get access to them. Now, I'm not going to talk about and go through how FME then manipulates this data, because any of your clients who have FME, they've probably been using it extensively and they know how to do that. So the main thing they just need to know and look at, they look at the attribute name there, and then they can do all sorts of things on them, rename them, decide which ones they're going to collect to write out in another format. So FME, they're the people who can look after that for you. So I was just really trying to go through, well, what possibly can go across to FME. And as you saw, virtually all our data can. The one thing that is missing there is called super tins, which is on my earlier list. That's because the nature of a super tin, all the separate tins could go out there, but obviously FME can't then process and make a super tin out of it. But all the individual tins could be written out and loaded into FME. So, excuse me, that's so that's a little bit. So this today is only going to be a fairly short webinar, because I just wanted to show you very, very briefly there, because most of you can understand though what it goes across, and that's the main thing you need to know. So in summarizing that, FME is not necessarily a graphic system. So it can draw some things, but it mightn't draw your transitions and things like that correctly, but can always just draw straight lines for things, because it's the start and end point that's important. But what it holds is all the information and values in there and attributes. So you know what people sometimes call the semantic information. So for your transition, you know all the fundamental information that another system would need about it. And so all that data can be manipulated inside the FME engine and then written out in various formats that you may want, or directly into some databases that want that information. So that's sort of how FME processes this data. And FME, it reads in 12D XML files, and that includes project attributes, super alignments with attributes, and that's including all the segment and vertex information. So you know, say everything about a transition. It also reads in superstrings, and in that case, you've got your string information. You then can have your vertex string attributes as well, your vertex attributes and your segment attributes, plus the information if it's a round pipe or whether it's got a width or a height, and if there's any thicknesses on all of those. All that information goes across so you can pass it on to another system. Water strings, again, they go out with all their information for the nodes and links, all the attributes that go with them, plus the information about the geometry, where there's arcs, or whether they've got round cross sections or similar things like that. So all that is there. Some of the more extensive information, we're working with FME to put all that extra information out there as well, because as you know, you can do a lot more modeling on extra information, but that's tri-meshes. So tri-meshes go out quite happily to FME, and so all that sort of data can go across. Tins with attributes, they all can go across as a mesh inside FME. It's only super tins that you're not able to pass across. And tri-meshes with attributes. So all your tri-meshes that you create, they can all go out with their tri-mesh attributes. And that's why with some of the water strings, that extra information, which is held as a tri-mesh, is still possible. Then it could be sent across to FME. And an important thing is that reading 12D XML files is in the base of the FME product range. So whenever you have FME, you're able to read in the 12D XML files. So I think hopefully I've given you a very quick overview of what's possible with FME. As far as who is using FME for this application, it's been used by quite a few of our clients already since it was in a beta form from about 12 months ago. And I know a number of people in big projects in New Zealand are actually using it, again, to take, in this case, a lot of survey data that's going into asset databases. So in this case, the surveyors can just provide exactly the information they pick up in the field, and then it's being processed by that client using FME scripts or workbenches, as they call them, to then get the data with the correct attributes, the correct names and things to go into their various databases inside that client. So it is being used already quite widely. If anyone's having any problems though, the good thing is FME are always looking at fixing anything and adding things to it, and certainly contact us as well so that we can actually help them in that process of making sure it can all read all the sort of data you want. So basically with FME, it does then mean that virtually any of your clients, you can hopefully just give them 12D XML data, which is your data exactly, so you don't have to fiddle with it. Or if there's something they can think about later, oh, I wish I had that bit of that attribute, it's all there in that 12D XML file. So you are providing them then with basically your one source of truth. This is exactly the data you've picked up, exactly the data you've designed, exactly the data you've manipulated. Whatever you've done with your data, you are giving it to them as your data, and then they can make their decisions on how they want to then manipulate it. So as I said, this has been a fairly short, because there's really only the various data types and then to show you what you can do with it, and see if there's actually any questions.
Thanks, Lee. We've had a few questions. I think a couple might be better handled by email. That just sort of might be a bit complex to do live. But Stephen has asked the question, are tri-meshes essentially solids that would write to IFC?
They go out, yes, so the tri-meshes go out to a FME mesh. So it's something that then in this case, it's made up of a whole lot of triangles. So if it's in 12D, it's a solid, the mesh goes around and comes back on itself. So it's a solid object. Well, that's what it would look like in FME as well. In fact, I think, if I just skip back a little bit. In this case here, there is an object that when it's gone FME, it looks very similar, as you can see there. And in this case here, there's a tri-meshes that have gone out for pavements and things. And again, you can see because they're closed, then they look that way in FME, and then you could write them out to IFC. So hopefully that answers the question. Yes, the closed tri-meshes go out as closed FME meshes.
Thanks, Lee. And Scott has asked, how do I get my clients to use FME?
Scott, an interesting question. I should have mentioned it during my talk. You probably don't have to get your clients to use FME. most of them may already have it, especially if you have any client that has a GIS system, such as councils or road authorities or rail authorities, because people with GIS systems tend to read in data from lots of different places and have FME to do that for them. So if you just ask them, do you have FME, I think you'll be surprised just how many authorities and things already have it, and probably large consulting firms who are running GIS systems. And you'll find the people there have been using FME for quite a while and will have no problems at all then just reading in the 12D XML file. That's simple. That's part of the base FME product. And then they'll know how to manipulate the attributes after that. So for a lot of the clients, I just don't think you'll have any problem at all getting them to use FME.
I thought that might be a curly one, but I'm glad that it has a good answer. Thanks for that, Lee. So I'll email you through some other questions after the presentation. And we've done a recording of today's webinar, so that will be available in coming days through the webinars page on our website, and I'll also email it out to everyone who registered, so it's a nice easy reference there. And so if everyone keeps an eye on our emails and social media for details of our future webinars. This will be the last one for 2020, but certainly in the new year we'll have some more happening there. And if you need to contact us in the meantime, we'll pop some stay in touch details on the screen. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.